washers as we go. R out, x plus 3, that whole quantity squared, right? That's R out squared, minus R in, x squared plus 3, squared again, all of this dx. So if we actually had to take this the rest of the way, we would have to expand x plus 3, like x plus 3 times x plus 3, do all our FOIL. We'd have to expand this, blah, 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 collect all our like terms together, and then integrate term by term. It would be pretty easy integration because they're all polynomial. This is a polynomial, so just power rule on all of them. I think we could do that given enough time, right? Think so? So equals dot, dot, dot. So on our next test, this is what I would expect. I would give you the first maybe problem or two on the test will be things like, hey, find the area between these curves. And I'm going to want you to take all the way down to the area. But then when we get to these problems, all I'm going to want is this, the setup of the integral. And that's it. I'm going to want you to box this and move on to the next question. Which means if you mess anything up in here, it's going to cost you dramatically. You need to make sure you're getting this correct. All right? Kind of got into an argument with, not an argument, but it got kind of heated in my 9 a.m. class because there were students trying to find like little shortcuts on how to get this formula without having to draw pictures. And I kept on emphasizing, look, just draw the picture. It's not worth you making a mistake because you couldn't get the geometry right. Take the 5 minutes or so it's going to take to draw the picture. Yes? If what?
Like, let's say it was on the bottom half.
If what was on the bottom?
Like the whole graph itself.
If the whole graph
No, the y.
was
Like
below,
down? Yeah.
like here,
Yeah.
then you would do the same thing. You would have to measure the distance.
But do you break it up the same way?
Uh-huh. Yep.
Can you have a graphic calculator on this?
You can have a graphing calculator, yeah.
But not for graphing.
Well, you can graph, but I mean, if you need assistance in drawing these pictures, you can use your calculator. That's fine. But the rest of it, I do expect to see this sort of analysis of what's happening. All right, you ready? Can I move on? I'm going to change one thing. Positive 3 instead. What's that going to do? Where's our axis of rotation now? It's above the region, isn't it? So I'm going to start with a brand new picture. I'm going to go a little faster with this picture because I already kind of know what it looks like. I don't really need the left side of it, so we know that this one was, the blue one was y equals x, and the red one was y equals x squared. Excuse me? They intersect at 1. I'm coming up here to 3. This is my axis of rotation up here. And yeah, they intersect at 1. I need to draw my little rectangle in here. And now I'm ready to try and kind of sketch out what's going to happen here. So bring your axis of rotation over first. Bring your rectangle over. And bring your x-axis over. Stand on your axis of rotation. Look out towards your rectangle. Identify the edge that's furthest from you. Stand here. Furthest edge is down here, right? That's our out. Here to here are in. You with me? What are they? What's that? R out is what? X squared plus 3? 3 minus x squared? 3 minus x? Let's see. What is the distance? What is the distance from here all the way down to the bottom? 3. That never changes, does it? That's always 3. X-axis isn't moving. This rotation axis isn't moving. That's 3 units. You know that because you were told to go from here to 3, right? So that full distance is 3. You don't want that full distance. You want to take away this much, right? So what's that distance? The distance from here to here. That's the bottom edge. That's x squared, isn't it? That's x squared. So the blue distance, which is your r out, is the 3 take away the x squared. You'll see that? R out is 3 take away x squared. Now's the time to ask a question if you have one.
Repeat the x squared part again.
X squared was the bottom edge of this rectangle, which corresponds with this bottom edge, which is coming from this parabola. And that parabola is x squared. That's how tall that is, right? So we want to take that x squared away from 3 to take us back up to here, right? I mean, the distance from here to here is x squared, but that's not our outer radius. Our outer radius is from here back to here. So we're interested in that distance, not this distance. What about the inner radius? Yeah, so you got this again, that's still 3, but this time from here to here is x. That's the top function. And so this in, our in, is 3 take away x. Pardon? They did kind of switch, didn't they? Because I was on the top side. But it wasn't plus, so what is the volume of this then? Pi integral 0 to 1. The outer one, 3 minus x squared, right? Minus the inner one, 3 minus x squared, and then all that dx. So you'd square out each one, combine like terms, do all your work. So dot, dot, dot. Okay, so I said that, on the test what's going to happen is I'm going to give you a region. You're going to have to sketch it, and then you're going to have to rotate it around 6 different lines. We've done 3, right? I gave you this region, I gave you the x-axis, then we moved it down a little bit, right? And then we moved it above the region, right? That's 3 things. What do you think the other 3 are going to be? Y-axis is next. We're going to try and rotate that around the y-axis. Then what do you think? I'm going to move it this way, make you rotate it this way, and then I'm going to move it on this side and make you rotate it on that side. That's the idea. All right. What do y'all think so far? I mean,
This test will do better than the last.
yeah, historically this test usually goes a lot better than the last test. Like my students do better on this test than on test 2. All right, we're going to take this thing now, and we're going to rotate this thing. Same region. Let's go about the y-axis. Something that I want to point out before we do this. On all the problems we just did, we had this, and we had that region, right? And we rotated around the x-axis. We drew a rectangle like this. And we rotated it, right? And when I moved this down here, we rotated it like that. When I moved it up here, we rotate it like that. Notice that in all 3 scenarios, the rectangle was perpendicular to the axis of rotation. Okay? So this and this, these were perpendicular to each other. Right angle, perpendicular, perpendicular, perpendicular. When we do washers, that's what we need. We need our rectangle to be perpendicular to our axis of rotation. There's going to be another method I'm going to show you today where, well, it'll be the opposite. The rectangle and the axis of rotation are going to be parallel. But we're not there yet. I just want to point this out now. All right, so let's go ahead and draw our region again. I'm getting kind of tired of drawing it, but give myself a little room here. So here's my region. I've got the y equals x. I've got the parabola y equals x squared, like this. And I want to take that region and I want to rotate that around the y-axis. And find the volume. Is that volume the same as the volume if I rotate around the x-axis? See, if we go around the x-axis, we said we got some object that looked kind of like this, that I could not put my hand through it, right? If we go around the y-axis, it's going to look like this. If you could see through it, it'd be something, no, hold on, those are straight lines. It would be like this. Do y'all see that? Kind of? These are not the same objects. Look, these have straight edges. This is curved like a bowl. These are going to have completely different volumes. All right. Let's do it. What's your thought process here? What are you thinking? Yeah, you're going to have to use rectangles that are horizontal. So we have to turn both of these in terms of y. So I'm going to draw my rectangle in here, mentally noting that my axis of rotation and my rectangle are perpendicular, right? These are perpendicular. Do you know the other word for perpendicular? I thought I heard. Have y'all ever heard orthogonal? Orthogonal is another term that we use to represent two things that are perpendicular. Orthogonal. How many of y'all have taken physics where you're dealing with the vectors I hat, j hat, k hat, I, j, k? These vectors are very important vectors because they are in three-dimensional space. They live like I hat is this vector, j hat's this vector, k hat's that vector. And they form what we call an orthonormal basis. What the hell does that mean? See, I can use hell all day. That's awesome. Okay, I'm just going to use hell from now on. I like it. No more bonus points. All right. Orthonormal basis means orthogonal. All of these vectors are perpendicular to each other. So if I look at any two of these, they're perpendicular to each other. All right? Orthonormal, normal means that the length of these vectors is 1. Any vector that's normalized has a length of 1. So these are 1 unit length. And basis just means that I can create any vector in the entire three-dimensional space just by using some combination of these three. All right. That was just, if you've never heard orthogonal before, it's the same as perpendicular. All right. What am I doing? I forgot. Get them in terms of y. All right, so solve these for x. If I solve that for x, I'm going to get x is what? Square root of y. And this one's a little easier. X is just y. And so keep that in mind because I'm going horizontal, everything's going to be with respect to y instead of x. So imagine these rectangles are going to be spun around creating washers. And I'm going to move the rectangles up and down to create all these washers and eventually create the entire solid. So now when I do my little drawing, my axis of rotation is here, my rectangle is like this, and my y-axis is actually there also. And now when I spin this, I just need an R out and an R in again. So wouldn't this be R out? And wouldn't that be R in? So what is R out? Yeah, it's just this curve, right? Now be careful, because it's x squared if we're looking at it as a function of x, but we've converted it to a function of y. So the R out is actually what for us? Root y. See, we've turned everything sideways, so we have to have things as functions of y instead of x. What's our R in? Just y. Questions on that? R out is a distance from here to here, which is the same as the distance from here to here. That's this function, but turned into a function of y. R in, same thing. I think we're in business. You need limits of integration, though. The volume will be pi. What about limits of integration? Where are we going to go from? Where to where? So are we looking at the x's anymore? No, we have to do this way now. So you have to know where they hit here and here, and it actually turns out to be the same. It's 0, 1 again, but because we're looking this way, we're looking at how our y changes instead of our x. So we still go 0 to 1. R out squared minus R in squared, right? What's R out squared? Y minus what's R in squared?
Change if you went 1 to 0.
Would it change if I went 1 to 0? Then our answer would be correct, but it would be negative.
Oh yeah, okay. So then if you subtract it.
Yeah, everything would be reverse sign. What else? dy. Okay, so we're using dy, not dx, because our little width here is actually our change in y instead of this way change in x. And then you integrate that, right? Dot, 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 dot. Questions? Could I say that we're bordering on the edge of fun here? Are we like, no, we're not. Okay. All right, so let's change it up. Let's rotate this region not around the y-axis, but around, let's go with x is negative 4. So what is x is negative 4? It's a line. What type of line? Vertical. So we have a vertical line at negative 4. We're going to take that region, we're going to wrap it around there. I can give myself some room here. Negative 4 is over here. Wrapping around this thing. So shall I go with vertical or horizontal rectangles? Horizontal, right? Because my axis of rotation is like this. So I'm going to draw my horizontal again. And now let's just transpose everything down again. So really there's like a little gap here. I'm just redoing this. My axis of rotation is here. My y-axis is here. My rectangle is here.